Hello student, today I am here with you to discuss class 9 chapter 7 mathematics class 9 chapter 7 chapter 8 triangles. Okay, basically it deals with the congruence of triangles. Okay, now what is the meaning of congruence? Congruence means coincide. Congruence means coincide. If you place one triangle over the other, the three sides will coincide with the three sides, three angles will coincide with three angles. Basically, it means equal in all respects. Two triangles are will be congruent if their corresponding sides are equal, their corresponding angles are equal. Similarly, you can say about the other geometrical figure also. Two circles of same radii are congruent. Two squares of same length of side are congruent. But we are here in chapter 7 basically to discuss about the triangles. So you understood the meaning of congruence? Equal in all respects. Corresponding sides are equal, corresponding angles are equal, the sides will coincide with each other, vertices will coincide with each other, and so the angles are also. Now, now next is to discuss the criteria for congruence of triangles. The number one is side angle side congruence rule. The meaning is that two sides of one triangle are equal to the two sides of another triangle. Pay attention. Two sides of one triangle are equal to two sides of another triangle, and the angle included between these two sides are equal, then these two triangles are said to be congruent by SAS congruence rule. That is in triangle ABC and triangle DEF. If AB equal to D, angle ABC equal to angle DEF and BC equal to EF, then triangle ABC will be congruent to triangle DEF by side angle side congruence rule. Understood? The next is the angle side angle congruence rule. Two angles of one triangle are equal to two angles of other triangle, and the side included between these two angles are equal. If two angles of one triangle are equal to two angles of another triangle, and the side included between these two angles are equal, then these two triangles are said to be congruent. That is, in triangle ABC and triangle DEF, if angle A equal to angle D, AB equal to D, and angle B equal to angle E, then triangle ABC will be congruent to triangle DEF by ASA congruence rule. You can say other way also, in triangle ABC and triangle DEF, if angle B is equal to angle E, if BC is equal to EF, and angle C equal to angle F, then also by ASA. Now sometimes this ASA congruence rule can be AAS also. You know why? See here. Suppose we have two angles of a triangle are equal to two angles of another triangle. We are known to angle A equal to angle D and angle B equal to angle E. And BC equal to EF. Then see, this will be AAS, but AAS is the not main congruence rule. What happened? If two angles of a triangle are equal to two angles of another triangle, then third angle will be equal to the third angle by the angle sum property of triangle. Let us see the, if suppose angle A equal to 60 degree, angle B equal to suppose 50 degree. Okay, so by angle sum and we are given all angle A equal to angle D. Angle D is also 60 degree. Angle B equal to angle E. The angle E is also 50 degree. Now by the angle, see first this triangle. By the angle sum property of triangle, what will be angle C? 180 degree minus sum of these two angles, which is 110 degree. Okay, so how much we will get? 70 degree. Similarly, now with the by the angle sum property of triangle, you can find angle F also. What is angle F? 180 degree minus 110 degree. Sum of these two angles. So even if it is not given, if two angles and two angles are equal, their third angle will be equal. So AAS is same as ASA. So we can use AAS congruence rule also. Understood? Actually, AAS is actually ASA only. So this is not the main congruence rule, but it can be understood by the angle sum property of triangle. AAS can be converted to ASA, so we can use here. Now, third is the side congruence rule. Very simple. If three sides of a triangle are equal to three sides of another triangle, then these two triangles will be congruent by side congruence rule. That is in triangle ABC and triangle DEF. If AB equal to D, BC equal to EF and AC equal to DF, then triangle ABC will be congruent to triangle DEF by, this is simple. Now this is also, last is the right angle hypotenuse side. This is not RHS, this is right angle hypotenuse side congruence rule. So obviously hypotenuse will be into right angle triangle only. Suppose we have triangle ABC and triangle DEF with two right angle triangles in which angle B equal to angle E equal to, it must be 90 degree, no, we are talking about right angle triangle. Now in these two triangles, if AC equal to DF, what is AC? The side opposite to the right angle is called hypotenuse. The side opposite to the right angle is called hypotenuse. That is, if the hypotenuse of one triangle is equal to the hypotenuse of the other triangle and BC is equal to EF, then these two triangles will be congruent by right angle hypotenuse side. It can be AB equal to D, either BC equal to EF or AB equal to D. So these are the congruence rule. The four, basically four only, but we can make it five. So these now we will use in exercise. Understood the rule? Side angle side congruence rule, angle side angle congruence rule, which can be AAS also, angle side also, and then the side congruence rule, then right hypotenuse side congruence rule. Now sometimes question is there, no? See, we don't have angle congruence rule. It will MCQ, which of the following is not the rule of the congruence of triangles. If it is given AS, you will say it's not a congruence rule. It is also not a congruence rule. It is also not a congruence rule. So these are not, these are not, these are not. So keep it remember, it will help you to do the MCQ. So these are the criteria for congruence of triangles. Okay, now you can start the exercise 7.1. Very easy only. In the most of the question, in all the question diagrams are given. So let us start number 1. We have given the diagram. So draw the diagram. Diagram is compulsory to draw in geometry. Here given AB, here C, here D. See, you can mark it. This is given. This is given. This mark has the meaning. Means equal. What is given? First you will write given. What is given? We have AC equal to AD, AC equal to AD, angle AB, angle AB bisects angle A, AB bisects angle A. This is only given, okay? We need to prove, we need to prove triangle ABC congruent triangle ABD. This is the first part. In second part, they are asking what you can say about BC and BD. That is later on. So now given you will write diagram is already there. So proof now, proof. So we have to prove these two triangle congruent. We will take these two triangle only. So now in triangle ABC and triangle ABD, we have AC equal to AD given, AC equal to AD given. Now, what is the meaning of AB bisects angle A? AB bisects angle A into two equal parts. What is the meaning? These two angles are equal. This angle is equal to this angle. So you can write the angle CAB. Angle CAB is equal to angle DAB. Angle DAB. Reason you must write, since AB bisects angle A. That is very clear. AB is the side of triangle ABC as well as triangle ABD. So this is called common side. So you can write AB is the common side. So thus we have got triangle ABC congruent triangle ABD by what postulate? You must write the postulate very clear, side, angle, side. What we will write? By SAS congruence rule. Now, if we have already discussed that two triangles are congruent, then their corresponding parts will be equal in everything. All aspects, sides will be equal to corresponding side, angle will be equal to corresponding side. So they are asking what you can say about BC and BD. So BC is the side of this triangle and BD is the side, and when we will fold it, BC will fall on BD. So these are called corresponding sides. So therefore, what you can say, BC equal to BD, corresponding parts of congruent triangles. So shortcut form, corresponding parts of congruent. Parts means either sides or angles. So that's all. It's easy only, understood? So we will go to the next number now. Question number 2, when the diagram is again given. Now they have given the diagram so that you can discover the triangle, they have developed your reasoning power and interpret the diagram. So they are the region here. This is joined to this and this is joined to this. This is AB, this is C, this is D. Mark here, it will help you to understand that means equals are given. Mark here, equals are given. It will be given in the given part also, and C and D are also joined. Now given, write down. What is given? We have ABCD is a quadrilateral. In quadrilateral ABCD, what is given? AD equal to BC. See, it is marked in the diagram also. Angle DAB, angle DAB equal to angle CBA, CBA, CBA. This is given. We need to prove number 1, triangle ABD congruent triangle BAC. BAC. Number 2, BD equal to AC. Number 3, angle ABD equal to angle BAC. Now see, first Target is to prove triangle ABD and triangle BAC congruent, triangle ABD and triangle BAC congruent. So what we will take? Start the proof now. Take the triangles. In triangle ABD and triangle BAC, we have AD of triangle ABD is equal to BC of triangle BAC. BC of triangle BAC given only. Okay. See, it is already marked here. Angle DAB. This is the angle of triangle ABD. Triangle ABD. What is the name? Angle DAB. You can say BAD also, but angle DAB they have given. So we will write angle DAB is equal to angle CBA, and this is the angle of triangle BAC. This is one of the angle of triangle BAC. Name is CBA ABC. It can be also angle CBA given. Okay. Now see, in the name also the hint is there. When you say triangle ABD, AB is there. When you say triangle BAC, AB is there. So common side. So you can write AB equal to AB common side. Or you can write AB is the common side, meaning is same only. So we have already three things, side, angle, side. So now we have triangle ABD congruent triangle BAC by SAS. Now if two triangles are congruent, their corresponding parts will be equal. Okay. So when you say BD is the side of triangle ABD and the side corresponding to BD is AC. So therefore BD will be equal to AC. This is called corresponding parts of congruent triangles. Not the sides also, angles also equal. ABD, this is the angle of triangle ABD. What is the name? ABD. So angle ABD is will be equal to this angle is equal to angle this of this triangle ABC. ABC. What is name? Angle BAC. Angle BAC. Corresponding angle. This is also called corresponding parts of congruent triangles. Basically, when you will prove triangle congruent, their corresponding sides will be equal, their corresponding angles will be equal. This is called corresponding parts. Parts means either sides or angles. So that's all. Hence proved. This was number 2. Okay. Now we will go to number 3 now. Here easy. This is basics only. So draw the diagram. Number 3. Number 3, first we will draw the diagram. Okay. Name is here A, B, here C, D. This is mark is given. This mark is for right 90 degree. You have idea. This is equal to this. In the given also we will write. This is the diagram. And name is here O. Now see here given. AD equal to BC given. Also it is given that AD perpendicular, see AD perpendicular AB and BC perpendicular AB. Both AD and BC are equals and perpendicular to AB. Okay, this is only given. We need to prove, this is given. But now we need to prove CD bisects AB. We need to prove CD bisects AB. This is the question. given and to prove. Now see here, what it means CD bisect AB? Actually, we have to prove that CD divides AB into two equal parts. CD divides AB into two equal parts means this part and this. So actually, we have to prove OA equal to OB. And here OA is the side of this triangle and OB the side of this triangle. First, you need to prove these two triangles are congruent. So start now proof. In triangle ADO, name of this triangle in triangle ADO, in triangle ADO and triangle CBO, triangle CBO. We have angle DAO equal to angle CBO, angle CBO. You know the reason? Perpendicular means 90 degrees, so you can write each 90 degree. Each 90 degree, okay? We have, see, this will not be given. When two lines intersect each other, we have done in chapter 6, they are called vertically opposite angles. So angle AOD equal to angle BOC, vertically opposite angles, okay? And AD of this triangle is equal to BC of this triangle. This is given only. We have already discussed. It is actually AAS, which is equivalent to ASA because two angles, this angle equal to this angle, and this angle is third angle will be equal by angle some property of triangle. Okay, so we can use triangle ADO congruent triangle CBO by AAS. We have the congruent rule AAS because it is equivalent to ASA. Okay, now if these two triangles are congruent, we have already proved, then their corresponding parts will be equal. Therefore, AO equal to BO. This side of this triangle will be equal to this side of this triangle because these are the corresponding sides of both triangles. They will be equal, which is called corresponding parts of congruent triangle. And if AO equal to CBO, then what is the meaning? CD bisecting AB. CD divides AB into two equal parts. So therefore, CD bisects AB. Hence proved. Okay, now we'll go to the next number. Number 4. Question number 4. First, we will draw the diagram. There are different lines. The name is, when you have small letter, with single letter can be name you line. This is PQ lines P and Q. This is L and M. Okay, they are parallel lines intersecting each other at point A, B, C and D. Okay, AC already joined here. Sorry, AC is already joined here. Okay. We have given P, L, and M are parallel lines intersected by P and other parallel line P and Q. So given you can write shortcut in your own way. L parallel M intersected by P parallel Q. Okay, we need to prove triangle ABC congruent triangle CDA. This is quite easy only. This triangle and this triangle we need to consider. In chapter 6, we have already the idea about the parallel lines and transversal. Since P parallel Q, okay, and AC the transversal, this line is parallel to this line, then this angle will be equal to this angle. Understood? P parallel Q and AC the transversal, then angle BAC equal to angle ACD. You can start the proof. Since P parallel Q given, AC is the transversal, therefore this angle, what is the name? Angle BAC. Angle BAC is equal to angle ACD. Angle ACD. Why? Because they are alternate interior angles. Okay. Give it equation 1. Again, L parallel M. Here, L parallel M. L parallel M given, and again AC is the transversal. AC is the transversal. So we have here, this is L, this angle. This is M, this angle. What is name? Angle ACB. Angle ACB equal to angle DAC. Angle DAC. This is also alternate interior angle. Alternate interior angles. Okay. You can give equation 2. Now, in triangle ABC and triangle CD, this is our target. Now, in triangle ABC and triangle CDA, we have angle BAC is equal to angle ACD is equal to angle ACD from 1. And it is visible, no? AC is the common side. So, you can write AC equal to AC, common side, and then this angle, angle ACB. Angle ACB equal to angle DAC. Angle DAC from 2 we have already proved. From 2. Then we have triangle ABC congruent to triangle CDA by what rule? See here, ASA. By ASA congruence rule. So that's all, hence proved. Okay. Now next question we go to number 5. Number 5. An angle is given. These are the arms of the angle. There is a line given. Draw properly diagram. We should use the scale actually. A line given. This line L bisects angle A. What is the meaning? This equal to this. There is a point here B, and from B, BP is perpendicular and BQ is perpendicular. Okay, this is diagram. What is given? The line L bisects angle A. Okay, B is any point on the line L. B is a point on the line L. From BP perpendicular, you can say AP. and BQ perpendicular AQ. BQ perpendicular AQ. We need to prove BP equal to number 1 also. To prove number 1, triangle APB congruent triangle AQB. Number 2, BP equal to BQ. Now, see the again given, there is an angle given A, the line L bisecting angle A, this angle equal to this angle. There is a point B on the line L, and from B, BP and BQ are perpendiculars on the arms of the angle. So actually we need to prove this BP and BQ are equal. For that we need to prove this triangle congruent this triangle. So proof. In triangle ABP, APB and triangle AQB, what we have? Angle BAP, angle BAP equal to angle BAQ, angle BAQ. Since L bisecting angle A, since L bisects angle A, okay, perpendicular means 90 degree, 90 degrees, so both are each 90 degree only. So angle APB is equal to angle AQB because they are each 90 degree, okay, and very visible. AB is the common side, so you can write AB is the common side, or you can write AB equal to AB common side, meaning is same only. So therefore, triangle APB will be congruent to triangle AQB by, understood, AAS, AS, which is equivalent to ASA, so we can use it. Okay, therefore BP equal to BQ, CPCP. Hence we have proved. So this is one of the, I use a theorem also. See, how can you use a theorem? Any point on the bisector of an angle, any point on the bisector of an angle is equidistant from the arms of the angle. Can I repeat? Any point on the bisector of an angle is equidistant from the arms of the angle. So this can be used as this theorem also to prove the other sum. So okay, today till here only. In the remaining sums we will give in the next class. Okay, if you have any doubt, any comment, anything to ask, you can write to us, you can message us. If you understood, you find it easy to please share to your friends. And if you have not subscribed the channel, please subscribe it. So see you next class. That's all. Bye bye.